next speaker is Aaron Waters from SCC, who's going to be talking about H5 gizmos. Take it away.
Okay, am I working here? Everything okay? All right, I assume everything's okay. I'm going to, just to connect to the previous talk, I'm going to show you a gizmo that uses WebGL here. So if I can get it to work. So this is from some MRI data. It's a isosurface viewer, and it's built using H5 gizmos and WebGL and 3.js. So just to connect to the previous talk, let me talk about, now let me launch into my own presentation here. All right, so I'm going to be talking about introduce the H5 Gizmos interactive visualization platform that I created. And it describes how, and it's describes I'm going to dive in detail to a use case. Okay, now why am I not seeing? All right, I'm just going to not deal with that. You guys can see it.
Oh, it's on your screen.
Yeah. So do you know how to switch screens?
But this screen is showing the full.
Right.
Yeah, use the button at the top. If on the other displays on the other screen.
Yeah, can you move your mouse to that?
Where's the other screen? Am I in the other screen?
Oh.
All right. I can't see the mouse. Where is it? I love PowerPoint. Can we just deal with that? I'm going to move forward. Okay. I've worked with a group at Princeton in mouse embryology, and I built a bunch of tools for them, primarily using the infrastructure I'm talking about. The infrastructure lies, sort of underneath the visualization. You build a visualization on top of it, but I'm going to be talking about some of the, for motivation, the stuff on top a little bit. So if you look up on the upper right, that is a registration tool where you can look and see between different timestamps. You can see where these the red and the cyan are nuclei from the same mouse embryo at different time points, and you can see whether the embryo has rotated and whether the alignment adjustment has worked correctly. You can also fiddle with the alignment and potentially save it, but no one actually uses that. This thing on the lower right is a sort of advanced 3D visualization, again using WebGL and 3.js to visualize the mouse embryo, in this case after a large number of divisions. And then I'm going to delve into in great detail, or at least show you a demo of the lineage viewer, which is the other tool on the lower left, which shows you the complete history of divisions of cells in the mouse embryo, and how the cells divided. It also shows you the microscopy imagery and the segmentation data. And I'll dive into that one in greater detail further on. But this is the elevator pitch. This is what I want you to take away. Thank you very much for sticking around on a Friday afternoon. You can go to sleep after this slide. What I want to do is, I would really like to fix that if I could, but oh well. Yeah, if you could.
You can keep talking.
Okay, yeah, you can. There it is. Okay. Excellent. Thank you so much. All right, so H5 Gizmos infrastructure leverages standard web technologies and Python libraries to support the development of special purpose interactive visualizations. It's specifically designed to aid researchers in scientific workflows. And in particular, I use it for my own development, and people who work with me use the tools that I build using it. As far as I know, I'm the only one actually using it at the time. It is intended to be used by other people, both as developers and as users. And I'm hoping that will happen. A few people have it started on GitHub and stuff, but I'm not sure they're actually using it. So you can launch a gizmo on, for example, on the compute cluster, and then view it in any connected user-facing device. And on the compute cluster, there's a Python parent process, has access to all the Python scientific tools and anything that Python has access to. So it can also access, for example, an R. You can embed, you can talk to an R process from Python and visualize it using an H5 gizmo. And on the other side, the JavaScript HTML child context can be on any connected device that's on the network, that has a network connectivity to the cluster. You can even do port forwarding. I've done that. All kinds of tricks like that. And there's, importantly, on the JavaScript side, no installation is required. All you need is a standard browser. Fix this. All you need is a standard browser with standard tools, and it works. So let's move on to the most interesting use case I've used this for, which is the mouse embryology studies that are being conducted by the PostSpy lab in Princeton University. What they do is they take mice, pregnant mice that have recently been impregnated. They take an embryo out of the mouse and they stick the embryo into a gel, and they stick the gel into a fancy microscope here. And the fancy microscope keeps the mouse embryo alive for several days, while under normal circumstances, it would be moving down the fallopian tube, I believe, before it embeds itself into the uterine wall. So between the single cell stage to several hundred cells, they can get microscopy data for the embryo. And it's three-dimensional data every few minutes, every like 10 minutes, every 5 minutes. So they end up with hundreds of volumes. And the interesting thing is to try to figure out, what is happening? How are the cells moving around? How are they dividing? How do, what structures in timestamp 6 correspond to the same structures in timestamp 7? And they have they've been working on lots of problems related to that. And one of the tools to help them look at the data and tell whether the system is working correctly and also just see what's going on that I built is called the lineage viewer. So the lineage viewer over on this side, we can see microscopy data. On this side, we see cell segmentation where they've identified cell structures. And then here, there's a lineage tree where you can see the cells as they divide. So now let's try to do a live demo, assuming it works. So this is actually from a talk I gave at a conference. So that's why it's called Prick Demo. And so what I just did is I launched a Python program, which is the Python parent process I mentioned earlier. In this case, it didn't start up a graphical user interface. It just provided a URL. So what it's actually done is it's created a little web server, and that web server is waiting for something to contact it. So let's connect to that web server. So there's our user interface. Here is microscopy data on the left, segmentation data on the right. In this case, it's not the nuclei, but the membrane. And then you can see there's you can't see very much because there's noise in the microscopy data. However, if we blur it and get rid of the noise, then the image will equalize so that you can see a lot more structure. We can also say, okay, let's only look at the structures that have been identified and even get rid of anything that's not in that hasn't been identified as a cell structure. And then you can rotate this around, look at it from different angles, and you can move forward and backwards in time. Come on.
Aaron, could you give just an idea of how much interaction there is right now between the front end and the back end? Was the data transferred all at once at the beginning, or is there still communication?
So every time, so for example, yeah, okay. So if we do this, every time you do this rotation, it's doing a numeric Python operation on the back end, and it's transferring the image across. So that's real-time Python computations going on there. Another thing you can do is you can say, all right, if we move to an interesting timestamp here, you can say, okay, one of the things that's pretty useful here is these XXXs. That means there's no data. So there's something in this tree that doesn't correspond to anything that's in the images. So that's the kind of thing that pops right out in terms of like what the scientists need to see.
So every time you move the slider, you're issuing a network request. Something on the back end is running and then delivering the result back.
Right.
All in that, like.
Yeah.
Wow.
Well, yeah, it's more like
Still,
quarter of a second or something, but yeah.
So does the back end, is it keeping this object in memory then?
Yes. The Python process keeps so that's why this load takes a little bit of time, because it's actually loading in the data. Yeah, so another thing we could look at is we can say, okay, this cell division, I want to see what that looks like, and I only want to see that. So then you only see the structures that you've identified, and you can rotate them. And see if that looks plausible. And in some cases, you find out, oh, that it identified a division, but it looks like it identified the wrong daughter cells. So, that's the kind of thing you can find from this. So that, unless there are additional questions, that's all I want to do for the live demo at this moment. Yes.
So once you visualize something and you like the way it looks, is there any capacity for rendering out a pre-rendered movie so that you can just play it back at a higher frame rate for talks and things like that?
Well, okay, these images, yeah, you could do that. Yeah. It's not implemented, but it would require a little bit of implementation. But yeah, you can do that. I mean, basically, these are actual images, so you could just write a little Python program that creates those images. I could add a button which does that, possibly. If you gave me a little bit of information about how you wanted it to work.
Can you say what the total data set size is? I mean, I guess it's dominated by the volume. It's volumes over time, right? So
right. So the source microscopy data is huge. Right.
Is that what are you generating these 2D projections from?
I think it's, in this case, it's actually I've sliced it so the totally uninteresting areas have been sliced out, but even that is pretty large. It's gigabytes.
Oh, okay.
On the server side, and well, the only thing that's going to the browser are these 2D renderings. So everything else is staying on the
right.
On the back end, which in this case, the front end and the back end are both my laptop. But
cool.
So when you say this gigabyte, is that or any one data set with several gigabytes, like 10 gigabytes?
I'd have to measure it. Well, yes, let's see. I think it's hundreds of megabytes for every timestamp. Yeah. So, all right. So that is the live demo with that. If I have time, I'll be showing you some more live demos. So going back to PowerPoint, so look right. Let's do the view. Okay. All right. So that's slide, wrong direction. All right. So what's going on under the surface? When you launch the Python parent process, it stands up a little web server. The web server waits for you to contact it. When you go to the browser and paste in the URL, it loads an index.html page, which also loads a whole bunch of other, and loads a whole bunch of JavaScript and CSS files and images and stuff to get the thing started. And ultimately, once everything's initialized, it sets up a WebSocket control connection, which communicates back and forth to the between the two processes. And then hypothetically, you could capture GPU results or large images using a post to send data from the child web context back to the Python process. But that's sort of this is a general idea of what the underlying protocol looks like. And let's see. So this is kind of similar to some other things that are out there, which are, for example, Jupyter widgets, or Streamlit, or Plotly, or Bokeh. And the biggest difference is probably that the JavaScript interface for the H5 gizmos is much simpler than any of these. And also, for example, well, if you're looking at Streamlit, for example, it doesn't really support real true two-way communications. Like the slider I showed you just won't work in Streamlit. And also, I think there's an issue with Plotly Dash. Bokeh is the closest thing, but as I say, the JavaScript interface is much different. So let's do another quick demo. Oh, I wanted to show you maybe I'll do that really quickly. Let me show you the source for the perk for the. So how do you connect? How do you start this thing up? How do you get the lineage browser? So to launch the lineage browser that I showed you, I use this little script. What it does is it says, okay, this is the data for the tree structure. It's a JSON data file that's been from upstream processing in MATLAB. And there's also an assignment of the numbers that are used to identify the structures in the label images, and the numbers in the assignment data structure are different numbers. There's an assignment between them, so that's what the assignment's for. So you identify those two structures, then you tell it for any given timestamp ordinal, where is the image and where is the label. So here's the image pattern, here's the label pattern, and then that tells it how to identify all the structures, and then you just start up the viewer, and then down here, I'm saying serve the viewer and give me a link to it. And so that's just to show you that, I'm not, when I get a new data set from the people at Princeton, I take a script like this and I usually modify these two lines. But let's look at the Google example as well to show you how easy it is to add use new JavaScript. This is like directly from one of the Google examples. It's using Google Charts. And the key thing is this line, or these lines right here, which says, I want you to load that JavaScript library. And then, yeah, load that JavaScript library, basically. And then the rest of it is like, okay, here's the data and the configuration for the chart. And then here's the, here's the little dance to get the chart started. Right. So on the onload callback, okay, so this says when you're ready, when you've loaded and you've initialized, call this draw chart function. The draw chart function is a Python function, but it's being called from JavaScript. There's a little magic going on there, which I'm not going to go into. But it's basically you can take a Python function and treat it just like it was so yeah, this syntax is exactly the same syntax you'd see in the Google documentation. And then this is just standard draw the chart and then serve the task. And let's see what it looks like if we run it. So there's the chart. That's not very interesting because it doesn't do anything. Let me show you one that does something. It's just so you know what interactions look like. Oops, I'm in the wrong place. Where did I put this? No, yeah. Okay, in this case, we have two sliders. And this is a MATLAB chart that's being updated in real time. So let's look at what the code looks like for that. So this is just standard matplotlib, except that the last line is commented because we're not actually going to show it. What does the show operation is this thing up here. Matplotlib is not a very good piece of software because it uses global variables, and this with thing handles those global variables without going into the details. And then the slider, each of these sliders says, okay, create a slider, and whenever the slider changes, call the draw plot function, which was up there. And again, that gets passed straight to JavaScript as a Python callback. And that's it. I have 7 minutes, so I will talk a little bit more about technical details, unless there are questions.
Yeah, a quick question for you. So when you say it's passed to JavaScript as a Python callback, does that do you have like certain functions that the Python server has registered as it's capable of doing, or are you getting Python code
It
from
uses
JavaScript?
Python introspection. So it detects the fact that it's a callable object. It stores the callable object in the Python process using a special data structure, and then creates a proxy object, a message basically that it sends to JavaScript saying, I've got this thing that we'll call Python. Create an equivalent JavaScript function over on the other side. And then that JavaScript function gets put in whatever data structure it needs to be put in and gets called later. And when the JavaScript executes that, the proxy function says, oh, this is a proxy to a Python function. It sends another message back to Python. Python executes the function.
Okay, so there are certain Python functions that are registered. You're not allowing JavaScript to call arbitrary Python functions.
Arbitrary functions. Any function you pass to a JavaScript, and so I can
but
pass.
You have to choose to expose it. I mean.
Right. Well, you do by the fact that you're passing it to something that gets passed to JavaScript. So all of this stuff gets introspected. It's like, oh, this is an integer. I'll just pass an integer. Oh, I pass it as a JSON integer structure. This is a function. Oh, okay, this is a function. I'll wrap it as a little callable Python thing. Create an equivalent message, so it doesn't actually send the function across because that's not possible. It just creates a data structure, sends a message across saying, I have this data structure, create an equivalent JavaScript function for me, please. So that's all right. So now, now I'm into question space. I guess I will stop here, except to mention that one of the things that occurred to me, well, there's another thing called a gizmo server, which allows you to serve many gizmos and also allows you to embed gizmos in the gizmo infrastructure as what's called a Jupyter server plugin. So you can distribute this with Jupyter. And in addition to that, you can do things like put the Gizmo server inside a Docker container and basically use the Gizmo infrastructure to provide graphical user interfaces to something that's been encapsulated in a Docker container. And so those are some of the technical details I wanted to mention. And now I will stop and either ask for additional questions or move on.
We have time for a few questions. So
I was wondering about the name H5 gizmos. What does the H5 mean?
HTML5.
Okay.
Because it's based on HTML.
Like the backend data is, or?
Well, it's based on the HTML5.
Oh, HTML5. I was thinking of HDF5. Okay.
No, yeah. So, and the gizmos maybe was a mistake, but I decided. I mean, because there's other things called gizmos, and I didn't realize it at the time, or maybe I think actually subconsciously I did, and I just thought it was a cool name. So, because I didn't want to call it widgets, I didn't want to call it thingamabobs. But I figured it's a gizmo, but then there's something. Well, you work with gizmos a lot, so yeah, the CCA guys have gizmos too, so that's confusing.
So how much back and forth is there between you and the lab, or like in this case in Princeton, I guess, to add more features for like selecting volumes or removing cells or doing stuff? Like I imagine there's probably, you've added some features and based on what the lab needs, how easy is it to add new things? And is that a sort of ongoing thing, or is this a static? Are you done?
It's for this tool. I actually have outstanding requests at the moment. Yeah, right. And sometimes it's easy, sometimes it's not. The one that they have outstanding right now is that right now the microscopy images, you can only see grayscale images for one channel. The microscope actually supports like 3 channels, so they actually want to be able to see all 3 channels at the same time in the microscopy imagery. And there's some technical details that need to be worked out on that because they're actually shifted a little bit. That's all. Yeah. Okay. Thank you.